This is electronic project presentation by Group 8. Our group have 3 members. The first one is me, Nabiha binti Zubatuahan. My metric number is TN240012. The second member is Nor Adiba. Her metric number is CN230406. Lastly, our member is Muhammad Zaki Zikri bin Rosman. His metric number is DN240029.
Assalamualaikum and hi, my name is Nabiha binti Zubatuahan. My metric number is DN240012. Today, our group will present our project on the design and simulation of the third order active band pass filter or BPF. An active band pass filter is an electronic circuit that allows signal with a specific frequency range to pass the alternating another outside the range. This is achieved using operational amplifier, resistor and capacitor. This filter is essential in many electronic systems, especially in signal processing, where only specific range of frequencies need to isolated. Common applications include communication system, biomedical device like ECG machine, and audio system. In our project, we designed a third order band pass filter. This is achieved by cascading a first order high pass filter and second order low pass filter. This approach gives us sharper transition from the pass band to the stop band, improving frequency selectivity. Unlike passive filter, active filter provide gain, meaning they can amplify signal while filtering. This makes them ideal for IoT device, 5G system and AI integrated technology. Now, let's go into the theory behind the circuit. We were required to design a filter with a lower cutoff frequency of 3 kHz, an upper cutoff frequency of 20 kHz, and a mid-band gain of 16. This gives us a bandwidth of 70 kHz and a center frequency of around 7.746 kHz. The filter consists of 5 ohm, 4 of the filtering stage and 1 for amplification to achieve desired gain. The main equation used in the design include cutoff frequency Fc equal to 1 divided by 2 pi Rc. Center frequency Fo equal to square root Fl multiply Fh. Bandwidth equal to Fh minus Fl. Quality factor is equal to Fo divided by bandwidth. The voltage gain from non-inverting op-amp AV equal to 1 plus Rf divided by Ra. Based on our calculation, for the half-pass filter at 3 kHz with a 1 microfarad capacitor, we choose R equal to 53 ohms. For the low-pass filter at 20 kHz, R equal to 8 ohms. Each ohm end stage gives a gain of 2, so the total gain after 4 stages is 16. To reach our target gain of 60, we add a final ohm amplifier with a gain of 3.75. Using the gain formula, we calculate Ra equal to 267.67 ohm when Rf is 1 kilo ohm. In summary, our design filter successfully meets the design specification and theoretical expectation. In calculation guide, the component selection and the circuit structure ensure accurate performance. That's all for me. Thank you.
Assalamualaikum, and my name is Nora Diba. My number matrix CN230406, and this is our circuit, and our component that we use is resistor. The value is 3.3 k ohms. The quantity that we use is 2. Resistor for RL 3.3 k also. The quantity is 2. For the resistor RF and RA 1 k. Resistor RF U1 is 5.9 k. Resistor RA U1 is 1 k. And for the capacitor SCH and CL 330 PF. And for the IC OM, TL081, voltage 60 volts. We use a TL081 because the value that we can get highest if we use LM 471 741, it have a limit and max, that because we use a TL081. This is our result for input and output for voltage and current. For V-in, we get a 100 voltage, and V-out 60 MV, and V-in 45 mA, and I-out we get a 60 UM. Okay, I will talk about analysis and discussion. For the low frequency theory, we get a 5K, and the simulation we get 5.8K. And the high frequency we get a theory 30K, and the simulation we get a 30.24K. And the gain theory we get a 60, and the simulation we get a 48.5. And the gain theory dB we get a 35.56 K, and the simulation we get a 35.5. And the simulation setup in Proteus: input AC sine wave generator set at 120 volt with a frequency swept, and the output measure using an oscilloscope or voltmeter. Use a TL081 of M, power at 60 volts. For the resistor and capacitor, we are connected as per design. For the emitter, placed at input output to measure circuit.
Assalamualaikum, my name is Muhammad Zaki Zikri Birasmai. I'm going to talk about discussion and elaboration. Importance of active filter and their role in current technology trend. The first one is remove unwanted noise and interfering in electronic signal. Then amplifying signal while filtering useful in low level application. Compare design without bunking inductor, ideal for modern electronic. High input impedance prevent signal distortion from previous stage. And lastly, easy to design and tune for specific frequency range. Besides that, relevant to current technology trend, electric vehicle and renewable energy, reduce EMI, improve system performance. And last is 5G and wireless communication, precise filtering in RF circuit. In conclusion, the third order band pass active filter using a operational amplifier is an important and effective tool in modern analog signal processing. By combining multiple filter stage, it achieves better frequency control and reduce unwanted signal more frequently than a low order filter. Using a OM add advantage like signal boosting, high input resistance and simple design without needing large inductor. This makes the filter compact, effective and easy to use in many electronic devices. Its ability to control center frequency and bandwidth precisely make it ideal for application like audio system, communication device, measuring instrument and medical equipment. As technology advance and the demand for accurate filter grow, this type of filter remain essential for a clear signal processing and better system performance.